Okay, this is the submission for the video questions on quiz1 for Cade Johnson. This is me. Hi. So, question 2 is the first video question. So, the way that I came up with this as the position time graph for this velocity time graph was firstly I looked at this, and the velocity is positive, which means that it would be going up linearly, so that's reflected in here. Then it goes negative, and there's a line that connects these two, which means that this is not a parallel line with the x, because then it would just be a dotted line. So that's reflected in the little, there's a curve instead of just an angle there. Then there is a more negative slope here, so that's reflected in a steeper angle of between 2 and 5 on here. So there's that. Then it continues with that between 2 and 5 here, so it continues with that slope between 2 and 5 here. Then there, between 5 and 10, there is an increasing slope, and so you can see over here there is an increasing slope here until it ends at 10. So that's my velocity time graph, or that is my position time graph for the velocity time graph here. So then the second video question is question 5. So quite a bit here. So to find the maximum altitude for the rocket, you have to first, where is it? Okay, first you have to find v of x. To find v of x, you use this formula. I rearranged it into that, and then came out with 180 meters per second. And then now that we have v of x, then we can solve for x, and up here, and we have to find x because to be able to calculate the max height, we have to have x. So solve for, this is the equation I used, then there's my answer. Now that we have x and v of x, now we can solve for max height. So you use that equation, just solved for x sub 2, because that's what I'm looking to find. I'm looking to find that right there. So came out with 2014.56 meters. Then after that, and that was one of the questions. That was letter A. So then to find the velocity of the rocket right before it hits the ground, we just use, I use this equation right here, solve for what I need, and then plugged it all in. I got 198.71 meters per second. After that, we were finding we were doing C. I was doing C. And then how long is this rocket in the air from launch to hitting the ground? It's 42.65 seconds. You can see that I had to calculate T3 because I didn't have that already. And then I had to calculate the time between 2 and 3, which was 18.37 seconds. Then I added, well, I'll just go up here and show you up here. I added 20, 18, and 4, and got 42.65 seconds. That is my whole problem here. It was quite a doozy. Anyway, thank you.